Hello, live listeners.
Hello.
Hello, world.
Still waiting. There it goes. And we're live. Awesome. Okay. And yeah, I've confirmed that you're all in frame on YouTube. So that's good. Cool. So any questions? Actually, I have one more question for introducing all of you. I know how to say your name for us, but Brett, and do you go by Mick or Mikola?
Yeah,
or?
you just go by Mick.
Okay.
Yeah,
How do you want me to introduce you?
It's fine.
Mikola Lysenko or?
Yeah, I go by Mick though. It's fine.
Okay. And then Brett Combs.
Yep. Good to meet you.
You too.
So you listen to JS Party a lot?
I'll listen to some of the episodes if somebody I want to hear what they have to say. I don't do everyone, but I've definitely
weekly is a kind of a lot. So
I've definitely listened to probably more than 10. So
Nice.
Yeah, I don't get much uninterrupted podcast consumption time because a lot of stuff going around.
Oh yeah, for sure. I used to when I drove more, but now I.
Yeah. Driving is podcast zones.
Commute time
or dishes.
Dishes is good, yeah. Okay, so real quick for Brett and Mick, the way that we'll try and break this down is when we start here, I'll set a timer and we'll just try and shoot for 15 to 20 minutes of talking about something, and then we want to try and add a place for an ad break, and so we'll kind of take a break and you can get a drink or whatever and then we can kind of regroup about follow-up topics or things that we want to dive into next, and we'll do that to basically break it up into 3 15 to 20 minute segments each, and then that'll be it. And am I missing anything?
So you got your recording going over there?
We got our recording over here. Let me just double check. It's still going. Yep, it's still going.
You're supposed to avoid cuss words, or Jared has to bleep them out, and he gets annoyed.
But if you do, that's a good point. If you are talking and we're talking over each other or whatever, that happens because there's a little bit of a latency here. But if that happens, you can just pause and then restart what you were saying, and we can edit it to make us sound like we're all really smart and know exactly.
Back off protocol.
Which one? Analyzing existing code versus PRs? Yeah, okay. Yeah. Also, if you want to if you get asked a question, you can pause for as long as you want before starting to talk. They'll cut the pause out, so there's no rush, time pressure or anything. You can just collect your thoughts as long as you need.
Yeah, and I can just think about it, and I'll visualize all possibilities in the future, some kind of
automatic
quantum guru, whatever.
Okay.
I don't need exclusive even though.
Cool. It's just good to know. I mean,
yeah. There's stuff we can all talk about. Yeah.
Cool.
All right. Any other questions before we get started?
I stretch my cheeks out so I articulate.
Let's do some vocal exercises and then.
Round mountain.
You got all the hosting stuff figured out, Nick?
I think so. Yeah, we're all live and recording, and
I retweeted it.
Makes it easy. Oh, good. Yep.
Yeah.
And then, okay. So I'll play the intro music here in just a second, and then I guess I'll jump in and start doing some introductions, and then kind of turn it over to you three to introduce Socket as a whole. We'll kind of, while we want to avoid just duplicating the changelog show, which I think will be just fine, we also need to make sure that we cover the ground for anyone who hasn't listened to that, so we get a basic understanding of everything that is Socket. Cool. All right. So let me go ahead and play the music. All right, here we go. Once it tells me it's live. There. Hello, party people. Welcome to JS Party. I'm your host this week, Nick. Ahoy, hoy. And welcome. We are very excited. Well, first off, let me introduce my co-panelist here, and that is Chris, aka Boneskull. How's it going?
Hi. Great. Super.
Woo! Welcome back. I haven't been on a show with you in a long time, so I'm very excited
Yeah.
to be here today.
Yeah, I hope to not disappoint you.
You never could. And with us as well is JS Party regular Feross, Abuka DJ. How's it going, Feross?
How's it going, Nick? It's great to be here.
Yeah, welcome. Now we are talking about a very exciting new project from you called Socket, and you have a couple of guests on as well to talk about that with you. So first off, we have Mick Lysenko. Mick, how's it going?
Hi, going pretty good.
Awesome. Tell us a little bit about yourself.
Yeah, I mean, I've just been doing a lot of Node and JavaScript stuff for since like the pretty early days of these things.
Nice.
I did a bunch of like WebGL things, and like maybe 10 years ago, and I've done some work with numerical computing. Then previously, I was out in China working on some MMORPG browser game thing, which is still running basically. But now I'm back in
Nice.
America post COVID and working on this.
Nice. Very cool. That is like a lot of wildly varying things I was going to say. And then I realized
There's more stuff. It's the abridged version. I don't want to talk
Oh,
about
for
it.
sure. But
Yeah.
that's like such a cool and unique.
Yeah, I got a
segment.
blog actually, 0FPS. It's got a bunch of like voxel things and like stuff like that.
Oh, nice. 0FPS. We will add that to the show notes.
Yeah.
So people can check that out. And then with us as well, we have Brett Combs. Brett, how's it going?
Good. Great to be here.
Welcome. Tell us a little bit about yourself.
Well, I'm a software engineer and open source citizen. I've been doing Node for a long time, since like maybe 012, and contributed to a lot of projects and worked on a lot of little small projects of my own. And yeah, so just kind of living the JavaScript life. So.
Nice. Very cool. Well, yeah, I think it's safe to say that we're all JavaScript fans here. And so we're talking about this exciting new project that the three of you are working on, which is called Socket. Frost, do you want to take it away and tell us what Socket is?
Yeah, sure. So Socket is a platform that protects your apps from supply chain attacks. And a software supply chain attack is when a JavaScript package gets taken over by a malicious actor. It can be compromised, hijacked. We've also seen maintainers go rogue and sabotage their own packages. And when this happens, the apps that you're building that use open source packages will get compromised as well, because they're built on open source dependencies. The average app has something like 95% of the lines of code in the app coming from that come from open source packages. And so the average JavaScript app has thousands and thousands of these dependencies. I think last I checked, the Hello World for React, a lot of React apps is like 1,000 dependencies. So there's a lot of potential for bad things to happen if any of those get compromised. And so Socket's sort of an attempt at solving that problem and making it safer to use open source.
Very cool. That is awesome and terrifying. I'm just thinking about that React example. Like, it's so nice that I can easily spin up React and have a hello world immediately, but there's so much happening that I don't know about because I've never really dug into what's actually being pulled down.
Mm-hmm.
To be fair, that one is particularly egregious. So,
Yeah.
It's actually kind of surprising that bad things don't happen more often. So I mean, it is still a relatively rare event, but even like rare events like at scale are actually like very common. Like at a certain point, it's just even yeah,
Yeah, that is a good point. It's, generally people seem to be pretty good about, being good stewards of open source. You all are a very good example of that. And but when supply chain attacks do happen, you hear about them a lot, and it's happening more and more because so much, like, we have so much more interconnected dependency on open source, or seemingly so right now. That any kinds of problems like this just immediately rise to the top of our attention feed.
Yeah,
Well-
it's both a blessing and a curse, right? I mean, we can build apps so much faster because all this great free code is out there, and for the most part, it feels pretty costless to add dependencies to your app. It helps you get your job done faster. It helps you solve problems that you might not even know how to solve yourself or not want to go and learn how to solve. And that's why you can build stuff so quickly today. That's why a team of like 2 or 3 people can build a really complicated app that would have taken like teams and dozens of people to build before. So it's really great. We're not against using open source. We just think that with the threat of supply chain attacks increasing, we need to take some steps to responsibly use open source. And in the same way that like it's become pretty common to scan for vulnerabilities in your open source packages, we think that scanning for supply chain attacks is like a logical next step that the industry and kind of all developers need to start thinking about and implementing in their apps to make sure that their open source is safe from supply chain attacks.
So a question I've seen thrown around recently is why does this seem to happen in JavaScript land? Why is it like a thing with npm packages? And I mean, of course, there's a lot of speculation as to the reasons why, but why do you think it is?
I think it's because there's sort of the scale of the JavaScript ecosystem is so much larger than every other ecosystem. So like kind of like rare cosmological events, like when you have just the large scale, like I was saying before, like when you have large scale numbers of things happening over and over every day, like
Right.
people installing packages every day, things getting published every day. Even if it's a very small probability of somebody introducing one of these vulnerabilities, like just the sheer number increases the count of those that you see.
Yeah. Also, it's like everyone has some JavaScript in their tech stack, right? So it's like, back in the old days, would you, bother writing viruses for some obscure Linux that runs on like a toaster? It's not worth it, right? So if you're an attacker, you're obviously going to go after JavaScript because that's where the money is, right? So yeah, we're going to see them there. And then as it gets like more locked down and we figure out how to fix it, they're just going to, like, the little cockroaches will scurry off to the other places where it's more vulnerable, right? So like, we're coming for you next, Maven. We're coming for you, Python. We'll get you. But they're on the list. They're just next. That's all it is. We're just the biggest, so we're gonna get hit first.
Yeah, that is such a good point, though. Like, you won't, if you're not a JavaScript developer, if you're not a Java developer, you probably won't be using Maven. If you're not a Ruby developer, you're probably not using like Ruby gems. But all of those projects are probably using npm because if they touch the web, they probably have some JavaScript in there. That really highlights like how I'm forgetting my words, how like wide ranging and vast the JavaScript landscape really is compared to other languages.
The other element to this is that Node introduced recursive or nested dependencies early on in the language, so the community that whole like module system essentially scaled like too well, like relative to the state of like Python or Ruby at the time, like which had shipped like module systems that still sort of required system level dependencies where you couldn't have 2 projects installed at the same time on your system. Just by default, you had to use like extra tooling, and so there was sort of an intrinsic sort of like resistant, or not a resist, like there was some pain there involved. Whereas in Node, it was just the natural thing. You could just install anything you wanted. There was almost no cost initially, that's sort of what caused it to scale up to what it is today, in a sense. So
Yeah, the average NPM package has 79 dependencies. Is what I saw in a paper from earlier in 2021. I find that hard to believe. That seems like a lot, but yeah, that's what they found. 79 dependencies,
Does seem
Does that
including
include
transitive, obviously.
including transitive dependencies?
Yeah, like a total. So they said the average NPM package had 79 total dependencies. Yeah.
That seems low.
Are these
Depends on what corners of NPM you
Are
hang
those for
out in.
packages
Yeah.
or projects? Because there's also that distinction where projects tend to use a lot of dependencies and packages will use a few less, but they also multiply in the package. So
Yeah.
is that for just
I
modules?
think they were looking at all the packages on NPM and then
Okay.
just like figuring out how many total dependencies they had.
That's wild.
But yeah, I mean that seems high for the part of NPM that I hang out in. Like I guess people different. There's like so many sub communities in NPM, and
In
maybe
the
there's-
React ecosystem, that sounds about right. So.
Yeah,
Maybe they're
being in the React.
dependencies too. So
yeah, they're probably including dev dependencies. Yeah.
I can tell you, being like I have switched over my like Git workflow to exclusively using work trees in a bare repo, and that means that I'm constantly like creating new work trees and then npm installing and then deleting those work trees. And on my M1 Mac, it takes about 5 minutes to just delete the node modules. Like it just sits there and hangs. There's so much going into all of that. That's not a very scientific number, but it takes a long time because there's a lot there, which is amazing. Now, so there are a couple of tools out there. NPM specifically has an audit command that tells you like some information about packages that you're using, and it highlights some things in yellow and red, and tells me and yells at me a lot. And then there's other companies like Sneak, I think, that I've seen like on PRs and things like that. Can you tell me how? Like, what does Socket do differently, or how does Socket compare to the existing landscape that's out there?
Yeah, so I think it's worth maybe just spending a second distinguishing between vulnerabilities and malware.
Okay,
So,
yeah.
So yeah, I think like vulnerabilities are when the maintainer of a project makes a mistake in their program. They introduce a security bug, and then a security researcher usually finds it and reports it to the maintainer. They get it fixed, and then a report is written up and goes into a database of all the known vulnerabilities. And basically, this database just tells you which versions of packages you ought not to use anymore, and what the safe version is that you should update to. And that's basically what stuff like npm audit and Sneak are looking at. They're basically looking through your project and making sure that you're not using any of those versions that are known to have problems. And that's great. Everyone should do that. It's useful. You don't want to be running code that is known to have these problems. Now that's very different than a supply chain attack or malware getting into a package, because when one of those gets into a package, it's it's usually it's not like a thing that you want to run on your computer for even like a moment. You can run a package that has a vulnerability on your computer, and it's it's gonna be fine. You can even deploy it to production if it's like a low severity vulnerability. It probably won't affect you for a long time or ever, right? Especially there's a lot of these vulnerabilities that I don't know if everyone is familiar with regular expression denial of service, but that's the one that we all see constantly in npm audit, and that's it's in a lot of stuff, and it's bad, but it's not the end of the world.
especially in a CLI.
Yeah, especially in a CLI, especially in dev tools, right? So that's why vulnerabilities are good to get rid of, but they're not kind of it's not going to be the end of the world. In fact, you probably have multiple known vulnerabilities that you're ignoring right now in your project and just like hoping to get to later, right? Whereas if you have even a single supply chain attack in your node modules folder, like you're going to have a very bad day if that happens, right? You're going to have cryptocurrency miners running on your computer. You're going to have your environment variables being sent off to some random server, to an attacker. You're going to have, passwords being harvested from different apps on your computer. You're going to have your files being deleted. These are all like attacks we've seen in the last few months that are real supply chain attacks that have happened. So, this is a kind of a different threat because it's so much more, drastic. What happens is so much worse, and it's also a thing where you don't really have much time to react to it. So when a package is compromised, if you install it at, at any point after it's been compromised and before it's been like caught and removed from the npm registry, then you're owned, right? You have to like, it's bad. You have to kind of clean up your servers. You have to like probably redo your whole computer and assume everything on it has been tainted permanently, right? It's not a good place to be. And so you don't want to have a very like reactive approach where you're kind of like, waiting for these reports to be written and like get added to some database, and then the tool to check that database, right? That's just too slow of a process. And so you really need something that actually can like look at the code and figure out, what is this code doing, right? What is it actually, its behavior going to actually be, and to warn you if that behavior has changed in some way that's really suspicious or like indicates that it might be a compromise in some way, and then warn you before you run it, right? Before you install it and before you run it on your own laptop or on your production servers. So that's the difference. Socket looks for that, and it needs to therefore have a proactive approach. That's very different than existing tools. So
how does that work in practice? Is Socket act kind of like as the gatekeeper, sort of, to upgrades, or what happens there?
Yeah, essentially. I mean, so the current thing we provide is a GitHub app that you can install, and it watches all changes to the package JSON file, package lock file, yarn lock, whatever you use, and it will monitor that. And when a new dependency is added or a dependency is updated, we'll look at it and try to figure out whether it has security issues. So the current thing you can go install on our website just looks for typo squats, which is like one of the number one, I think it's the number one or number two supply chain attack that happens right now, which is basically when somebody registers a name that's like 1 or 2 letters off from another popular package and hopes that people accidentally will install it. So we look for that, and we'll warn you if one of those dependencies is about to get into your app. And we have a bunch of other things we can detect on our website, which we're now going to work on adding into our GitHub app as well, to protect you from other stuff like suddenly an install script is added, or suddenly network access is happening, or suddenly files are being read and sent to some server, that kind of stuff. So that's coming in the coming weeks and months.
Is Socket mainly targeted towards applications and not necessarily libraries?
I think it can be used on libraries too. Yeah, anything that has a package JSON file with dependencies in it. So a library can use it to protect itself and make sure that its dependencies are good. So yeah, there's no reason why you couldn't use it there as well.
I mean, I certainly want it to be like, I want it on my modules. Like, I want to get warnings on my Dependabot updates. Like, if there's something weird about them, or like something fishy is added in this new package. So.
Yeah. You can kind of think of it like almost like if you're using Dependabot, you should probably be using Socket too, right? Because like if something's automatically bumping your versions, you ought to be like automatically checking those versions, basically. So like if Dependabot says like update this, then maybe in the future Socket will say like, well, hold on, maybe take a look before you do that. Right? That might not be a good idea.
Right. A lot of these supply chain attacks that we've seen, though, tend to be in like transitive dependencies, and you may not have, you may have pinned your dependency, but your dependency didn't pin the transitive dependency, and so anybody pulling down your app or your library or whatever is going to get that new version installed, right? And so it's on that user like to go and use Socket too, right? It's not like my problem anymore because. Or how does that work?
We actually
like,
scan all.
Yeah, we scan transitive dependencies. It's the whole dependency tree for all packages and all versions that you have on there. So it's a holistic, deep scan of all dependencies.
Of course, this is assuming that you have a package lock file in place. So if you have a package lock file, then we'll look at the actual versions that you're installing, all the way down the tree.
Yeah, if there's just a package JSON file, the best we can do is kind of make a guess about what npm install will do. But there's always going to be a race condition there, because npm could update, between when we do the scan and like when you do the deploy. So for safety purposes, you should just use a package lock file. But if it's not there, you can make a pretty good guess about what's going to happen. So we do the thing as like a fallback.
In module development, though, like even if you have a package lock for your development and your tests, like the consumers who are installing you, like they don't get those guarantees that your module does, right?
Mm-hmm.
Sorry, that's what I was trying to say.
Yeah.
So it's like I think we're still thinking about like that use case.
You could do npm shrink wrap, but that can sometimes cause like dependency, like exponential bloat, basically. So you gotta
like as a module maintainer, I I actually appreciate and practice the package lock free development workflow, because in some sense you get a more accurate picture at any given moment, like what your actual consumers are going to be seeing. If you test against a lock file with a module, you actually might miss you rerun that test, it's going to work exactly like you ran it that like 2 weeks ago. But if you ran it without the lock file, like you'd actually see what it's doing today. So I think we're still kind of brainstorming like how to handle that use case. I've thought of ideas like kind of like other products have sort of done like almost like a cron test on things just to see like what's going to happen without the lock file. So maybe there'll be something like that in the future.
Yeah, in the future we can also rerun them, but there's still going to be some delay between like when we detect the change and then when the analysis is actually done for that. And then like if you deploy before it's done, then you're going to miss that. So like practically speaking, the only way you could actually be confident that what you're sort of testing and deploying is what's actually running is to have a lock file, right? So if you're consuming and deploying NPM packages, you definitely need a lock file set up, right? And if you don't want to do it, that's fine. It's your choice, right? But you're taking a risk, basically.
Yeah. So ultimately, like if you're deploying a project to some sort of production environment, like that's kind of that line will, if they have socket installed, they'll get sort of the analysis at that level for the entire tree as well. So that's kind of the idea at the moment.
Yeah, so just use a log file, man. Like, why wouldn't it be so weird about this?
Well, I look forward to what you come up with in the future for module authors and library authors.
Yeah, for modules, it's really that's the thing. I mean,
there's kind of a gateway, like a little gate in front of like projects getting deployed to production, and that's kind of the gate we're at right now. I'd like to see it move more into the module ecosystem as well. Like, for example, like maybe rather than just reacting to changes in the pull request, like we could, open an issue if something weird shows up in your whole tree. So
if a new version of a transitive dependency has been
like a
published,
weekly or daily report or something.
Yeah, that would be pretty cool.
Yeah. All right, let's break right there for our first segment.
Nice.
Yeah. This is
one
moving.
Yeah.
Yeah.
No, is
yeah.
that one question? No, that was it was these two.
Oh, really?
I kind of
We didn't
ignored the
just
NPM audit thing.
Okay.
Yeah.
I need just a sec. I'll be right back.
But we got the analyzing existing code versus PRs, maybe.
Did that make sense?
Mm-hmm.
Okay.
Yeah. I'm worried we're getting a little
gonna
too
get
into the weeds with the module author stuff.
It's an important use case,
It is,
actually.
yeah.
And it's like the more nuanced version because of the like lack of lock file guarantee on install. So
Yeah. There are like a lot of questions I want to ask, but I'm very terrified that they're just like rabbit holes that we'll jump into.
Probably.
I'll definitely.
We can just time
box
it. Like no matter how
we've all had coffee too.
We stop at like 5 minutes or whatever.
Yeah.
We can take a break if we need to. Bathroom.
Yeah. We're on a break. Chris stepped away for a moment, so we're waiting for him at least.
Wait, so what question are we on? What are we on?
I think the last one I asked was about, it was kind of the combination of the NPM audit and the like compare and contrast with Sneak.
Oh,
Right.
I was gonna give NPM audit like history.
Yeah. Well, I actually, I don't really want to like put too many words into NPM audits, mouth, right? Because like they probably have it like pretty good strategic reasons for why they did what they did, right? The interesting thing though is like it might be more useful to contrast NPM audit with Sneak. Like, what is actually the difference between those two things? That's a good thing to think about, maybe. But I don't want to like go into that right now because we've sort of addressed it already.
Mm-hmm.
I mean, just say how is. Yeah, I don't know. Yeah, I'm not too interested in speculating on.
Yeah, I don't want to. I don't want to put words in their mouth, but
Yeah.
I think that they claim that they like have more vulnerabilities than like what NPM audit has found, because NPM audit just uses like GitHub's database, and Sneak has their own like extra stuff that they magic that they add in.
And they got a bunch of people in India, I think, like working for pennies, like on Fiverr or something, like just scanning GitHub commits. I don't know what they do actually.
Yeah, let's not put that in the.
Cut that out. Cut it.
It's a good example of something.
These are things I shouldn't say, right? Yeah, I don't know.
They have
Um,
security researchers on staff.
Yeah. They're very good actually. They probably do a good job.
One thing I was going to bring up as maybe a suggestion, and you can tell me if it's a good idea or not, but like maybe looking at kind of what is exposed to you when you look at a package on Socket. So like I'm looking at React right now, and like kind of going through, what can I, or what takeaway should I take from looking at React in that way, or like any package.
That particular package, by the way, has an interesting issue right now because React doesn't publish their tests. They actually move their test script from their package JSON for some reason, which is a thing I've noticed. They basically are trying to publish the minimal package. Are we live right now? Or is this just like pre-show?
It's still I mean, I could bring this up as a question if you want to. Jump
Yeah,
in.
I mean that's just we have a but where we say basically we say React has no tests because they actually don't publish any tests and they don't even publish the fact that there's a test script.
There's actually something interesting here, right? Which is a thing a lot of people don't realize about NPM is a lot of people think like if you have a package, you could go click on the repo and then you can look at the code and see what's going on in the package.
And
which is
we're going to be live.
This is actually wrong, right? Because the code that's on NPM is in no way, shape, or form linked to the code that's on GitHub.
Right.
So, and React is a classic example of this. What they publish to NPM is not what you see on their repository. They actually do like a bunch of like weird stuff to kind of like do that. And like, I mean, it's probably okay. It's React, right? But if it's like some other package, you would probably be a little sketched out by that, right?
We should probably put this in the show.
Yeah. So this is actually one of the things we
let them start the show and then we can put it in the actual show.
All right, sorry.
Should we just go right here?
Start it.
Okay.
I was trying to, by the way, I was trying to reload and I'm getting a 524 error on.
Sorry, I've just made that mistake before where I've like talked for like 10 minutes in the breaks and then it like it doesn't like.
Okay, I got it. I have to be sensitive to the format, like what's going on here. So.
All right, so I'll just kick off with that question, and then we can go from there and see where we go next. All right. So you have this site socket.dev, and it's really cool that you can go in and just start using it to search for packages on npm, and then you can get information. Like one thing that I really like about it is there's a score for different things like supply chain security, quality, maintenance, vulnerabilities, and license score. I love that. It's like not to compare it to Lighthouse, but it is like almost that approach of like kind of gamifying your security, which I think is really cool and a good way to get people to pay attention to it more, for better or worse. And so like I was just curious, like if you could walk through a little bit of what you get when you go look at a package on socket.dev. So like I'm looking at React, for example, but like any package, what is it telling you there?
Yeah. So you want to start?
Sure.
Yeah.
And then you can take it. Yeah. Mm-hmm. So when you go to a package page, you get those scores you mentioned that are they're basically a composite of a bunch of different issues that we look for. So we do static analysis of the package and look for specific like what we call issues or red flags. They're basically like things that you want to know about in a package. Stuff like the package uses the file system, talks to the network, runs shell commands. Maybe the package looks like a typo squat, or it's unmaintained, or it's deprecated, or it's known malware, or it has high number of CVEs, or it was refactored recently with a major refactor, or it doesn't use an open source license, right? There's all these different issues. We have like 70 plus issues that we look for. And you can find basically whenever a package has one of those that's really severe, we highlight it right there at the top of the page, so you'll know before you install it and add it to your project. And the cool thing is like if you use Socket, you'll even get told if a package has like an install script that's going to run, and we'll even give you a link directly to the Mick actually implemented that part where you get a link directly to the line where that where you can see what that install script would do. It's really cool. Yeah, you don't need to like run it, install it and then like be surprised that some install script is running. It's just like really a really basic feature that's super useful to have. So that's the kind of thing, and then we summarize all that into the scores that you see at the top of the page. And those are in beta right now. We're working on improving them, but they basically give you kind of this high level, like kind of summary of like, okay, this package has like a 0 on its supply chain security. Like maybe I should like figure out why, like what is it doing that's giving it such a low score, right? And maybe maintainers can, improve their packages by looking at that. Yeah.
Yeah.
Nice.
It's also, yeah, like it's not just like issues too. We also collect like a whole bunch of other statistics, and all of this feeds into the score. So like the lighthouse analogy is exactly where we're working from with this stuff, right? So, and expect the list of things that we check to get improved over time. The current version is very close to like a minimum viable product to get it up and running and like, bootstrapping
Yeah.
it. But every day we're adding more stuff and it's getting better. So it's going to keep improving in terms of what it can catch. Now, to go back to something earlier with
Hmm.
React, right? It's interesting that on the React page, there's actually a kind of bug with the analysis on that package where it says like there's no tests in React, which is actually true. Like there are no tests in the React npm package because React does is when they publish their package online, they actually go through and delete a whole bunch of code and like do some kind of complicated packaging build step to ship it out to npm before they do that. Which I mean, like, hey, I guess if they want to do that, that's, their choice, right? But what a lot of people would do if you're looking at, say, like NPM or some other website for inspecting a package, you typically would like to look at the code for that package before you download it and install it. And a lot of people, I think, may naively assume that the code that they see on the GitHub repository is in some way like related to the code that you get in your NPM package. But npm makes no guarantee that these two things are even remotely correlated. Like there's no like check that npm does that the GitHub repository code looks like the package code. And currently, like short of just installing the package, there's no easy way within the default like npm ecosystem to just like say, okay, what's going on actually inside this package? So at the moment, Socket does not really look at the GitHub side of things at all, right? We will bring more of that into our analysis in the future, but we're very like sort of focused on what's actually in the package. So all of the scores and all of the data that we have reflects the content of what you would get if you install it. So in the case of React, because they modified the code from GitHub, then they deleted all the tests. There's no tests in their package, right? So you probably want to like look around inside them, right? And this is actually a common way for people to like sneak in a vulnerability or something kind of sketchy, like if you're not looking for it, right? Because they can just say, oh yeah, I have a totally legit package on GitHub, but I could put something like sneaky in it when I send it out to npm, and then if you install it, you're going to get owned, right? But with the Socket, you can actually look at what's actually in the package and see what's in the code and like poke around in there, and we have like contextual links to navigation, and you can like look at what it's actually going to do if you were to install the thing on your computer. So, if someone's like going to go like AWOL or whatever, like delete tests or whatever, you probably want to know that. So in the case of React, we can probably in the future for tests, once we're ingesting the GitHub data, say like, oh, they don't have tests in their package, in their NPM file, but we found them in the GitHub repo, so maybe it's okay. But that's not implemented yet. Eventually, I think we will get there, but we're not quite at that stage right now.
Because this is like a debate. Should you publish your tests, right? In your experience, what percentage would you say of packages publish their tests versus don't?
From what I've seen, only extremely weird people care about this and delete their tests. I don't know why it's a big issue, actually.
It's an extreme optimization.
Yeah.
But
It's like, what if we delete all our white space in our package file too, right? We shouldn't publish anything that's not minimal. I mean, like, I don't know. Like, I guess if you really want to do that, but like,
some
why?
people also minify their files that they publish in their packages. I think like or like browserify or webpack the code so that there's only like one file that needs to be required, which can like
There's reasons for it to do that.
yeah, I'm not trying to like say that people should never do that. Like, there's definitely some pros to doing that, but it does definitely make it harder to figure out what's going on in the package.
Yeah.
Because you now open it up and it looks absolutely nothing like what's on GitHub, and you're just hoping that like nothing has been snuck in there. And so that's where it really helps like actually see like what is the code doing.
Right. And this is why, we have a concept of supply chain risk, right? Like it doesn't mean that they're doing something bad, but now it's more likely they could do something bad. And so if they're deleting tests, if they're like minifying their code and doing all this other stuff, you got to be a little sketched out about that, right? And like maybe, it's fine, but it's like processed food, you get a little bit of like, cadmium or nickel contaminants here and there, and like maybe one or two is okay, but the cumulative effect could give you like terminal brain cancer. All right.
The other thing too is like I think there's things we can do with our scores and with the things we like the the stuff we show on the package page to maybe encourage better practices. Not that we want to create like a lot more work for maintainers, but there are certain like things that best practices that I think like it would be great if we could make more normal. So something like being able to say, we took the GitHub code, we ran npm install, npm build, and then we ran npm pack, which is what basically simulates a publish and then gives you a tarball. And we compared it to what was on npm, and we found that it was identical, right? That's almost like the notion of a reproducible build, right? We could say this package, like you can go get the GitHub code and you can run those commands yourself, and you will be able to confirm that that's the code they put on npm. That's a great thing to know about a package, right? Versus some other package that might require random system libraries to be installed, and who knows what versions those are, and now the code doesn't even necessarily match, and so you don't know that what you're installing and running is actually what you saw in GitHub, right? So stuff like that, where probably like 99% of most packages, will be able to pass that test, npm install, npm build, npm pack, right? That produces the same thing, but some of them aren't going to pass that, and we should probably be a little bit more suspicious of those packages, right? And encourage them to.
You should take a closer look.
Exactly.
Yeah.
Would they have to have their dependencies pinned in their package lock in order for that to
Unless they're
reliably-
rendering it into their npm package during build, they shouldn't.
But I guess that could mean that that's a good point. He's making the point that I think if their Webpack version is like loose or something, then maybe it produces slightly different output. That is a challenge. Yeah, we haven't built this yet.
The other thing too is also going back to what you said. We don't want to make more work for maintainers. I mean, like the thing is doing all that extra packing, minifying, deleting test crap. I mean, like that's actually more work. We're trying to convince maintainers to like not do that because it like seems like you're helping, but this might be a case where like the cure is worse than the disease. Like just stop making it so complicated. You could just publish the damn files, right? Why? Because everyone's already running this thing through a build step anyway when they're consuming it. Like you're not optimizing anything that's worthwhile here. You're just making more like you're making like it's making more fragile basically, right? But people are going to do what they're going to do, and I'm sure people will argue with me about that philosophy.
But getting back to your original question, like you mentioned, you asked like how many packages have their tests published. The biggest number that you need to think about there is I think someone did. I saw this stat a while ago, so it's out of date. But something like 60% of npm packages don't even have tests, period, like at all. So it's not like they removed them; they just never wrote them. So that's the you want to know about before you choose a package. Yeah.
The other like just little piece of tidbit I'd throw out there as well is like back in the early days of Node, there were like a lot of sort of like DX design ideals around how like Node modules should work. And one of the original ideas was like you could actually just go into Node modules and like git init like the dependency and like make contributions out of your dependencies folder. And what we've obviously like gone far away from that. Like npm in some sense is like turned into a much more simple tool, which is just shipping tarballs to your local development or CI pipeline. But in some sense, it's like maybe you want to know like how is this maintainer treating this tarball? Is it just like a sort of built by binary packed thing that they send to you, or is it there's actually a strong connection with like the original source files?
Yeah.
So. It's not going to be like a serious penalty necessarily without it. It's just metrics that like it's kind of like a shortcut to like the idea is you look at the socket security report on a particular package, and rather than having to like go research these little details like we all know how to do as like developers and maintainers, like we can just kind of answer these questions a little quicker without having you to like dig around in the files tab and like see what it's actually doing. So
yeah. And I can see that, like, removing tests or doing like optimizations, like removing white space, things like that, being like holdouts from like the original days of JavaScript, where you're shipping to the browser, so you want to have as little things as possible. But it's also possible that it's just like accidental in the case of like, I don't know, maybe my entire like code base is written in TypeScript, and then the build command, is just looking at what files start from main or whatever, and tests are never part of that, and so it just never gets built out. And there really is no connection.
Yeah, that's why this stuff is going to be like important to get right and to be really, to be really kind of sensitive to. There's so many different workflows people have, and there's so many things people use npm for. like, we found, originally we had a bug where, we would find packages that just had CSS in them, and we would classify them as like, empty packages that don't do anything. But it's like, no, that actually, CSS packages, it's like a thing people use npm for. So like, okay, so we're discovering all these different things. Some people publish C code to npm and just use it. It's like there's so many things people are using it for. So
Exotic
workflows, yeah. So
we have ESM in the browser now, so you can actually publish like a real ESM artifacts to npm and then pull them out of npm with like something like unpackage or I think skypack or something, and get directly into the browser. In that case, like maybe you would minify it. Like maybe that's maybe the CDN should do it. These are kind of questions people are still exploring and deciding about. So
I still think it's premature optimization.
old school. Yeah, I mean the original there was no browser workflow out of npm when Node came out. Like it was always assumed that you would essentially download it to Node modules and then run it through a bundler first. So as things get stretched and bent, those assumptions start making less sense in some context. So
Now, one thing I'm curious about is going back to those, like, what did you call them? The performance or the security scores? Do you have a name for that?
The scores at the top of the page, yeah, we've just been calling them securities. They're quality scores or security
Quality scores. Okay, yeah. Is there a way, or do you see that, like, one cool, like, this is interesting, me looking at React and being able to see that, but I'm thinking more in terms of, like, my day-to-day application development. Is there a way that I could get scores similar to how I get Lighthouse scores for my app and how I'm performing it, that I could get this like as a total of
we're working on it right now.
Yeah, almost done.
Yeah, awesome. So right now it's like the Socket security website. It's like a really great research tool when you're looking at individual packages, and sort of the next stepping stone we're working on is generating reports like sort of specifically tailored for a project. So awesome. Like rather than having to go through individual packages, it's like we can just show you everything that's in it from like a high level view, and you can sort of makes that research task a little bit easier, and we can surface the ones that are interesting rather than you having to find them yourself. So
that's awesome.
Is your formula public?
Is it public?
The formula meaning like how each issue affects the ultimate score?
Yeah, I mean how the security score is calculated essentially.
Oh yeah. So you want to take that?
It's kind of like a messy. It's basically like an average of a whole bunch of like little statistics which are collected, and the thing is we're always adding more to it. So it's probably like I don't know, like does Lighthouse publish their score, or do people even care that it's public? It's just kind of like
it tells you pretty good.
I think we should publish it. I think it's basically like there's weights attached to each particular issue or metric. So it's something like it's probably helpful to people to understand where the scores come from. It's something we'd like to publish. I think it's just we're a small team and we're just trying to get something working right now, so we just haven't written up as much documentation.
It's not
about
stable
this.
enough that I think it's really worth writing it up, because like by the time you get done writing it up, it's going to be like, oh, we got to change it again, right? So it's not really.
The scores.
Those aren't stable.
We've been saying the scores are in beta because while the issues we detect are pretty reliable so far, I think the scores, like sort of how we weight each thing, it feels like there's a little work to go. There's a little bit of work to
require.
It's more or less just like a weighted average. It takes like some kind of like geometric harmonic mean thing of a bunch of different numbers. It's some simple statistical gadget, right?
It's very inspired by Lighthouse though. So the idea of like idea. Finding these issues and then just sort of like the more of the bad issues you have, the more the score goes down. That's kind of like intuitively.
Yeah, it's like basically like we have like this thing is like, okay, this thing is good if it goes better, this thing is bad if it goes worse, and then you just kind of like feed each of them through some kind of like distribution that reweights them, and then we take a weighted average of all those, and then we basically like sometimes like we also like feed it through like another thing that like adjusts it for popularity, right? So it's just like whatever, just a bunch of like random stuff. I don't know. It'll be a
grab bag.
It's a grab bag of like random little things. I'll write it up eventually.
It's kind of like every like little thing that goes. We tried to capture every little thing that goes through your head as like a developer when you're sort of like hand assessing dependencies
in the future,
and trying to like kind of codify those into like
I think you're giving it too much credit
yeah.
for what it is. It's more just it's about right. Yeah, it's in the future it'll probably be some like statistically normalized thing, right? Where it just looks at a bunch of different metrics, will calculate the distribution for every package on npm, and it'll probably be like a quantile deal, something like that, for most of the scores. That's what'll probably happen. And then you can like click on each issue, and you can see, okay, I'm in like the top 10% of packages here, or like this thing is like bottom like percent or whatever. So. Yeah.
Was that too much information?
Yeah. We're working on the product design of it.
We have like a lot of tangents.
Yeah. I don't know. You bring 3 people on, we're doing the product development right now, and this is what you're going to get. Sorry for putting you all to sleep.
No, I don't think you're putting us to sleep at all. It's just you're very passionate about it, which is awesome to hear. You working on it and just so excited about the product and the implications that it can have, which is
I
really
mean,
great.
honestly, I didn't care what the algorithm is. I just wanted to know if it was public. But
So he can gamify it.
no, but just because it's good to have that sort of transparency, or else people will be like, well, it's a black box, and then somebody's going to get pissed off about their score, and like, how do I improve my score? You know.
If you're mad at your score, you can blame me. It's my fault that your score is bad, right? So it's like definitely me.
Well, I think, I mean, it should be clear like what is negatively impacting the score and actions you can take to basically
Correct. The
release
reason
another
your score is
version.
bad
Yeah.
is because I hate you. That's what you can take away from this conversation.
No, Mick.
This is why we don't let Mick do public interviews.
Yeah, there was some there was like some like I don't know, should we let him on here? And then I'm like, I don't know, guys, do you think this is a good idea? No, that's actually like it's just there's bugs basically, and we're still working on it, and it will get better, I think. Right? I will learn to love.
So, like, I'm trying to think of how, like, as just like, a JS TypeScript developer working on, a day-to-day app, how should I approach introducing something like this into the app or to my team as something that they should care about?
Well, I mean, the easiest thing is to just install the GitHub app. It's
Okay.
kind of the primary thing where, like, if you want to go a step above just doing manual research of individual packages on Socket, you can install this GitHub app, pick which repos you want it to, be installed on, or just do all of the repos in your org, and then it will watch pull requests for changes to the package.json file and the other associated files, and then leave a comment when it sees typo squats. So far, typo squats is what the app does, and it's not a thing that happens super often, but when it does, it is something that you would want to know about, because it does have quite a lot of potential consequences, and that app will kind of expand with more functionality over time. We're going to probably introduce like a socket.yaml file that you can add to your project or to a top level repo that would control the settings of Socket and kind of what things it alerts on, kind of what it does, what actions it takes. But if you go ahead and add the current app today, it will evolve and expand into this more full featured thing over the coming weeks. But typo squatting it's a thing where if you add it today, probably you're not going to get an alert from it. Unless you make a mistake, in which case you'll probably be really happy that it sent you an alert. But the kind of stuff that it catches is stuff like, there's a package called browsers list that a lot of people use. I'm guessing you guys have used it or heard of it. Yeah. But there's a common typo people make with that, which is to install browser list, singular browser list. And that package is a completely different thing. It used to do something else, and then now it was removed from NPM. And it was a security holding package for a while, which makes me think somebody was doing something nefarious with it. And now if you install it, it just throws an exception instantly. So someone's, I guess, published something else there to kind of throw an exception and tell you that you've made a typo. But anyway, this is a package where there's no reason to add this to your package.json file. There's no good that will come from this. And in fact, we found, using Socket, we found a tool, actually Preact. Everyone knows Preact. The Preact project was depending upon browser lists and browsers lists. They installed both of them, right? Probably because someone typoed the first npm install and then typed it again correctly the second time, right, and forgot to remove the old package. So that's the kind of thing that if you install the socket GitHub app, we can catch. We can tell you, what are you doing installing browser lists? That thing has, that thing only gets 10,000 installs, every month. You probably wanted the other one, which gets 10 million installs every month, right? So that's what it can do today.
The other thing you can do that's like even less, rather than having to convince have an app install, is just start using the socket.dev website to research new packages or packages that are giving you hassling you in your project. You can find some weird stuff in there sometimes, like, oh, hey, look, this thing's like right into the file system, even though it's just like a date, picker or whatever. You can use it as like a way to, justify, like we should fork and make this better, or like we should just get rid of this. This thing's doing weird stuff. Like just a shortcut to doing research within sort of the transient dependency tree of various packages. So, and then once we have project reports out too, like that'll even automate that process a little bit further. But it will require the app install though. So.
Will like if I install or if I go look at a package on socket.dev, like I'm interested in installing this package, so I go and preemptively just do a quick check. Will it tell me about any like transitive dependencies that might be like trying to do shell access or anything like that?
Yeah.
Very cool. Okay, that's immediately like a
issues tab. There's two tabs in that. One's called package issues. The other is called dependency issues. The package issues are just like the issues related to the top level package, and then the dependency issues sort of collects all issues it sees through the entire dependency chain. So
yeah,
cool.
And we're going to be working on making this stuff like more accurate and like digestible too. So at the moment it's still kind of noisy, and like things will, some of them are like not ideal, but I think like it's actually kind of informative, and you can still find surprising stuff even in its current state. So it's and it's getting better. Like there's a lot of things that are like kind of almost working right now that we'll have out there pretty soon.
All right, let's break right there.
Nice.
I maybe you have to delete that last bit that I said. I feel a little bad about that. Sorry. Can we edit that thing out? Like just cut it out. Sorry.
Which part?
The part where I was like, it's my fault. Your scores are bad. Right? I don't know if that's going to go over right. I shouldn't make those kind of jokes. You just delete
make a note.
Podcast is probably okay.
It's on YouTube right now, but
That can be
this can be a YouTube exclusive, right?
That can be
like cut the entire like right half of the screen, like right here.
That can be the cold open. Just delete me from the podcast.
Yeah. Like this half of like this third.
No, I think it's fine. I think
I shouldn't. I didn't do these things.
reiterate, that was a joke.
Yeah, that was a joke, but sometimes people don't get it, right? But
yeah, I took it as a joke for sure.
no, I actually like I love Browserify, for example, and the supply chain score is 0, right? Which is like, that's actually not good. It should be higher.
Yeah.
It's got depreciated packages in it.
Yeah, it has some deprecated packages which are tanking it right now, so we have to change how that works probably.
It's funny because
deprecated is like overweighted, I think, right now.
A little bit, yeah.
Yeah.
it's funny because you said the browser list is the incorrect one, and originally you said browsers list. I'm like, no, you're trying to catch me with a typo right there, because I legit thought that the valid one was browser list.
I know that. It's what makes it a great example.
Yeah, it's a great.
Everyone uses it.
Browsers list is such a bad name. Like, why would you pluralize one, like the first word in the name?
Yes.
Like, oh my god. Yeah, I mean, I get why it's called that, but yeah, it's just unfortunate. It's really.
They could have called it Listo browsers.
And browser list, I think if you look up, like, it'll surprise you how many downloads that thing gets. The typoed package gets
15,000 a week.
Yeah,
15,000 a week.
and it does nothing except throw an exception immediately.
Yeah.
Like, what is going on?
Throwing weird stuff.
Yeah, maybe it's like actually important that they're using it as a they call it when they want to throw an exception, like it's part of their test suite or something.
Yeah.
It's a
Nick,
fixture.
we don't seem to have a whole lot of time left.
We don't. Yeah, we went a little long on both of those sections, so we only have, I mean, if we had a quick 10 minutes or less section, I think would be fine.
Okay.
I was going to ask Chris if you wanted to lead off with your question. I'm not sure if it will go anywhere.
Well, let me pre-ask the question because I'm not clear from what you said about Socket so far if it's ready to do anything about this. But like the what is it called? Peace not war or whatever. So if I'm a Socket user, like, was there something that would handle that in
Uh,
Socket? You know.
yes, it's not as optimal as it should be right now. But basically, for the peace not war thing, what we would
Hang
do,
on, if we can go into it in the show, that'd be
we
better.
actually have a flag that should be like that should trigger on this thing. So I don't know why it's not going on.
So do you want to? Yes, let's start the show, and then you can answer that. And you should also say what Peace Not War does, because I don't know if everyone knows
Yeah.
that.
Yep. Chris, do you want to lead this off?
Are we gonna have time to ask Mick about the pipeline stuff as well after this, like how the tasks run and all that, or is like
Yeah.
Yeah.
We can jump right into that after this.
okay,
Yeah.
cool,
And then maybe end the show on that.
nice. I don't know. I think that's pretty interesting stuff.
Yeah.
Yeah.
Okay. Well, I guess you don't have to go into a ton of detail then. So recently there was a supply chain attack, and a popular package, I think it was Node IPC, included another package which is called Peace Not War. And Peace Not War, first I'm not sure, it like started looking at your IP address and like zeroing out your hard drive if you live in Russia, and then it pulled that out, and I think what it does now is like creates a file on your desktop. I don't know, but I'm curious, since this was a big deal, like how did Socket approach that? What was the experience for a Socket user with if they had depended upon, say, Node IPC?
Well, at this point, we basically only have a GitHub app that detects typo squats, so it wouldn't do anything on Peace Not War. But once we have, like a fully, functional application that you can install, it would file like an alert that basically this thing gained the access to a file system at like the top level require. And so it would have alerted on Node IPC for this particular thing if it was like actually running. And then you get some message like, hey, all of a sudden, this module is accessing the file system when you require it, which is probably not what you wanted, right? And, so it would eventually do that. At this current stage, though, we're still trying to like get the like application sort of up, bring that up and running. And so it wouldn't catch it like right away unless you like actually went to the website and then looked at the package and then you would have seen it.
That's cool. Cool to hear that you have a plan like to address this, because I guarantee that won't be the last one. And
Yeah, that's the one that's the most important to address. Really, is like you've been using a package for a year, and then suddenly a new version comes out and behaves completely differently than it did for the last year, and someone's trying to bump that. Someone on your team is trying to update to that new version. Maybe it's Dependabot doing it, or maybe it's someone just updating all the dependencies, or maybe somebody deleted the package lock and regenerated it. However, it's getting updated. You want to know when the dependency has had that drastic of a change in its behavior. And that's what we want to do, is come and leave a comment in that situation on that PR and say, hey, you should know this project is now doing all this weird stuff, and here's the line of code. Here's a link to the line of code where it's doing that if you want to investigate further. Yeah.
It's basically a report of every new system call that's like added, like abruptly, essentially.
Yeah, and also where they're used too. So in the future, like probably within the next month, we should have like a more fine-grained analysis where it'll tell you like not just like does it use the file system, but like where does it use the file system and how does it use it. So it'll tell you like, we'll eventually have this thing where it'll tell you like, okay, if it's like you call a function with some arguments and then it reads from the file system, that's a very different thing than if it's like you import the module and then all of a sudden it uses the file system, or if it has like an install script that then does a bunch of stuff with the file system. So it's not just like does it use the file system, but where does it use it and when did it start using it. Like it's much more alarming if a package starts using the file system in like a minor version or a patch version update, right? And it previously didn't, than if it like was just using it from the very beginning and people have been using this module for all time, right? So we'll have that stuff implemented soon, and we're going to have an app that can do it. At the moment, though, you have to just look at the website to check for yourself, basically, to do that, right? But like we're trying to get this thing built as quickly as we can, and like we have all the pieces there. It's just not quite like up yet.
We're going as fast as we can.
Yeah, I know.
If you want to help us build this, send us an email. We're hiring. You can join Socket and help build this, and then we'll go faster, and then we'll have more features to talk about next time.
Yeah, it's like this thing. It kind of like it sort of announced it, and then the demand for this thing was just much greater than was kind of expected. And we're like, oh, we got to go a lot quicker now, right? So we're kind of in that like scramble to catch up really quick.
Sorry, there was one question that I had that I'm now forgetting. Oh, so when you're looking at for things like that, like flags that might stick out, can you talk about how maybe that pipeline works a little bit? And like, if I don't know, I don't know how you might do this, but if I mistakenly, set up a prepare script or something that installs or runs shell commands and then remove it out, like, am I forever tainted as like a vulnerable package on Socket, or how do I clear my name on things like that?
Yeah, I mean, so it's like each analysis is specific to each version and like each package. So, but it does like keep track of like which version introduced this line of code. So we have kind of like an NPM blame, as an analogy, blame that tells you like where things actually got added and like when they got added to a package.
Nice.
And so you can like see like, okay, this version was compromised, but maybe subsequent versions are okay. So yeah. And I think like at the moment, it's sort of just the facts type of stuff, right? It doesn't try to, like sort of, say like, oh, it was compromised at one point in the past and, we might report that. But if like the current version looks legit, it's okay. So yeah, that's basically what it is. It kind of looks at each version sort of, in terms of like when did things happen in that package, basically, right? If the current version doesn't have an install script, then it won't see an install script.
Gotcha. Okay. Okay, and I'm not seeing the question that you wanted to bring up about the pipeline.
Oh, wrote task graph tool in JS, is that open source? What is the granularity of parallelism? That's just sort of alluding to the changelog episode where they were asking us how we're actually analyzing all the packages on NPM. Like, how do we do that? That sounds hard to analyze 1.8 million packages plus every version of every package. So like, how do we build the data processing pipeline to do that?
Yeah.
Okay.
Well, the answer is we don't use Spark, right? We don't use any of these other tools. It's all kind of like a homebrew type of deal. But it's
let him ask the question though.
Sorry.
Okay. So as we've alluded to, NPM is quite popular, and there are a lot of packages out there. So how does Socket scale to analyze all of these packages and give you that in a timely manner?
All right, so I can answer this a little bit. Basically, what we've got is like a kind of in-house, like little homebrew, like sort of function compute type of system, right? Where basically like all of the packages are sort of like unpacked into a giant content addressable data store, right? Which is, like a giant immutable, like sort of, you could call it like a data lake or a data swamp or whatever, a data crypt, right? And so like they're kind of
a data swamp.
A data soup.
Is that a term of art? A data swamp? I think you just made that up.
I think that's a thing people say, right? But yeah, basically we just take all of like pretty much the entire data set of NPM, and then we just break it down. So we have like the tarballs, and then we have the files and the tarballs, and then like all of the package JSON things. We break them into this giant immutable data structure, right? That we can then query by just walking hash pointers, basically, to like search through that. And then we have functions which can read data from this giant, data swamp thing, and then generate new little blobs that go into this, giant immutable data store, right? So we can sort of do searches on this thing by like walking pointers. It's like basically like a tree or like a directed acyclic graph of pointers to blobs of data, right? And like all of the analysis, like running a linter, doing points to analysis, like parsing a file, whatever. Each of these things is just reading like a tarball, like sort of like walking through the contents of the tarball to read it out. It all happens like in memory, and it's like streamed in over the network. and they're all just functions. So like if one of them crashes, you can just rerun it, and they're all also generated on demand. So it's like if you go to a page, it can just say, oh, I need this data, which is this function of this hash, and then it can just walk down all those hashes and get all the data back and then return you the result. And if we've already calculated it, because they're just functions, we can memoize them to optimize the execution. So we just cache the results of them. So the parallelism happens at the level of functions, and we can also memoize them at the level of functions. And so you can even have things where it's like you have these very big, deep, complex function trees, but you can start calculating it. And if like it crashes halfway through, then the stuff that's already been done, you can keep it, and then it can just restart from that like next time, you know? Because it's like basically a user goes to a page, it starts crunching numbers, and then they navigate away. Then we can just cancel that whole task, and then the next time someone comes back in, it'll start calculating the rest, and then the results just stream back in as you're sort of clicking through stuff and walking around. And that's it. It's just we just got functions and we got data, and they're just pure immutable functions. That's all that there is. Right?
But all this is computed, lazily, right? It's not.
Yeah, of course. Yeah, it's on demand.
And so, do you have anything that like polls or sits on a feed and waits for new published packages?
Right.
Then?
Yeah, so the way that works is we basically tail like the npm package feed, right? And then you have sort of like a root pointer or whatever, which is like the state of all packages in npm, and then new packages come in, you build a new block and you throw it back in there, update a pointer, and then it redoes everything basically.
The following npm part is really important to be able to detect when new stuff gets published that's sketchy. So we, I don't know if are we currently running analysis on the
Yeah,
feed?
we currently don't have a thing in real time. I very briefly turned on like a Slack integration, and then it just spammed the thing, and we're like, okay, we need a better way to manage like inspecting this. So it's at the moment, like we're sort of reading it in real time as it comes in, but we're not actually looking at it as it comes in real time, if that makes some sense. So
we want to get to a place where basically like as a package is published, we just do the full analysis on it. And then if we find that publish was particularly suspicious, we can take an action. Like, for example, when we notice that a package suddenly has all these changes made to it, and it's maybe a new maintainer, or maybe it's something about it, like the collective publish just like looks like something's wrong, then we can take an action. So it might start off by being just like we put it on a page that's like suspicious publishes, right? Or we throw it on a Twitter feed, or we send it to a Slack channel that we look at, or but we want to eventually like take some actions based on that, such as like having a security expert actually look at it and say, oh hey, this is actually a really bad publish. Let's like go get npm to take it down right now. We'll tell them about it. We'll report it to npm, and we'll block it for anyone who has the GitHub app installed, so that they won't accidentally install this malware, even if npm still hasn't taken it down yet, because sometimes they take a few days to get back to you.
Yeah. So, but at the moment, like all of our analysis are kind of generated on demand. So, like if the thing is like a new package in the feed, we don't aggressively alert npm yet, because we just don't have people to look at and review all those things at this point. But if you happen to be like running, our current, we have like a temporary version of the GitHub app, but when this is actually like live, it will run the analysis on your packages as you like do a commit. So if you're using Socket and you have like a bad package in your package JSON file, you will definitely get the alert in a timely fashion, right? But it's like you probably don't care about all the new stuff coming into the npm feed because you're not using those packages. So from the user perspective, or like in terms of any question you can ask, the data will be there when you ask that question. It's just like, do we want to start aggressively like looking at the new stuff as it's coming in and having people like reviewing it? And like we will do that. It's just when we have enough people basically to do that, or it's like we've only been doing this for like a couple of months now, so we just don't have enough people yet.
Yeah,
it would be cool to eventually see some sort of hook for like a dev environment, maybe I don't know, a pre-commit hook or something that does the analysis before you, I don't know, maybe it's a pre-push, I don't know, but
yeah, that's exactly what we're gonna have. So you will have that.
We also talked about maybe doing like an npm proxy or like a CLI replacement that like also does a little check before you install stuff, because if it's out there, you don't, even if we catch it at the PR layer, like you're still like doing it on your dev machine, which has SSH keys and whatever else on it. So.
Yeah.
There's lots to build.
Those are ideas. Those aren't there yet, but like those are like we're not sure. Yeah, trying to like basically attack the things that are going to provide
Right.
the biggest amount of value first, and then we'll just
Right, and the other reason we do this stuff lazily too is because, like, as I've said multiple times and apologized for, and I know I'm joking a little bit, right? But it's like we are working on this thing and we're adding new stuff like every day, multiple times a day. So we're like constantly adding new things and we're improving stuff. And when we do that, it's like we can't just stop the world and like reanalyze NPM. So the other big advantage of doing everything lazily is that we can ship code so much faster, right? Like we can just push a new analysis and then, like, okay, the next time you check it, it'll update, right? And it'll, like, whenever you look at it, it's always going to be the most recent thing. So that's why we do it that way.
Yeah, that's awesome. Like that you have that infrastructure in place to lazily reanalyze things as you needed and as you're adding new features, which I was gonna like end the show by like asking, what's next or what's something cool, but we have spent the entire show talking about all of these amazing things that are coming that I'm so excited for. It really does seem like this could become like a super invaluable piece of your development workflow for everyone, for package maintainers down to people just working on everyday apps for companies. It could be so important to just use this as like a starting point for everything. Every time you add a new package, check socket first. Did I check socket? Did the socket bot come back and tell me anything? Like it's just really cool.
Yeah.
And
Yeah,
really awesome.
Yeah, and even though like there are, like things are not perfect yet, I still think that what we have now is actually pretty dang useful. Because if there's like an issue, it's often like a starting point for asking a question. And you can click those issues, and the key thing is we do have the actual data there, right? Like we're one of the, I think our presentation of the data inside NPM packages is currently the best you can find anywhere on the net. So if you want to go, like look around at like what's going on inside a package, you get like the issues, but they're kind of more just like a hint of like something to take a look at. But then you can take a look at it and you can navigate through the files, you can click links, and you can see the actual code that's in that package and all of its dependencies all linked together. So right now, like that works and it's pretty great. And I think, it's just a fun website to click around and play with. And we're soon going to have an app that's going to make this like 100 times more useful. Right.
By the way, the thing Mick's referencing is really cool. Like you can actually, when you're going into a package and looking at its files, you can click it's sort of like what VS Code can let you do, but it works across NPM packages. So you can click on like a package name and it'll jump you to the files in that package. It'll take you to the main file, but it'll do it for the right version too. It'll take you to the specific version. Yeah, so it's like you can actually kind of follow the tree of packages all on the website. It's really neat.
Nice.
Yeah, and like if you try to do this, like there's nothing that really supports that kind of workflow besides Socket right now, which I think is kind of cool, right? And I mean, like I personally find it very useful to just click around in the files on packages, right?
And thanks for all the kind words, Nick, and the feedback. The excitement. We're gonna try to make it as good as as we can, and make it something that's really useful to people, and make it live up to all of your hopes and dreams, hopefully.
Absolutely, and I think you're off to a great start, and there's a lot here and a lot of potential coming. So I'm very excited to keep going, keep looking at it, and to make it a regular part of my flow for sure. So yeah, thank you so much for joining us. I do want to mention that, and we've kind of alluded to it throughout the show, but Feross was on the Changelog podcast talking about Socket in more depth and different angles. So we'll definitely have a link to that show in the show notes as well. And thank you so much, Feross, Mick, and Brett for coming on. And thank you, Chris, for being here as well. And we will see you next time.
Bye.
Thanks for having us.
Yep.
Bye-bye.
We're doing like the rock head bob too. We're doing like the head bob.
Cool. Thanks, guys.
All right.
Appreciate
Yeah,
it.
thank you.
Yeah, thank you.
Yeah. Thanks for all the good questions and the enthusiasm, especially at the end there, Nick. What you were saying, I want to make sure that it's as good as you hope it will be. That's like
Yeah.
the thing that we're like.
The analysis was the hard part. So in some sense, like we're just kind of trying to catch up with the actual like how to tell a human like what this data is showing. So
Yeah, and like the accuracy of that analysis is getting better like all the time, and we're adding more stuff all the time too. So
And it's such a hard problem to solve that people really need to solve. So this really gives you.
Yeah, it's been around since NPM audit. I mean, like
Right.
the Baldwin guy,
Adam
Baldwin. You know,
Yeah.
he knew. I mean, everyone knew it was a
He
problem.
was trying to do something similar. He was using ESLint rules that he hacked together to like look for weird things in packages, and he was finding malware that way. But it was so hacky. He was just like doing it on, it's literally an ESLint rule that he just hacked together and was like trying to run it on all of NPM.
Plus, I think
Yeah,
back when he was trying, like, it's like he knew the problem before a lot of other people did it as well. It's like it hadn't been realized yet in a way. So it's like he was kind of like this solo, like guy just trying to like be like, "There's a problem, like leave me, Chicken Little." Like there's, but like, what are you talking about? There's no problem.
Yeah.
Well, that's where the Java people are right now, and eventually they're going to know that they have a problem, too, right? That's how I think about this. All
right, I'm going to turn off the